slightly changing perspectives, making over time and location on Earth about 59% of the Moon's surface visible from Earth. 154. Unlike most satellites of other planets, the Moon's orbital plane is closer to the ecliptic plane than to the planet's equatorial plane. The Moon's orbit is subtly perturbed by the Sun and Earth in many small, complex and interacting ways. For example, the plane of the Moon's orbit gradually rotates once every 18.61 years, 155, which affects other aspects of lunar motion. These follow-on effects are mathematically described by Cassini's laws. 156. Scale model of the Earth-Fi Moon system, sizes and distances are to scale. Scale model of the Earth-Moon system, sizes and distances are to scale. Minimum, mean and maximum distances of the Moon from Earth with its angular diameter as seen from Earth's surface, to scale tidal effects. The gravitational attraction that Earth and the Moon, as well as the Sun, exert on each other manifests in a slightly greater attraction on the sides of closest to each other, resulting in tidal forces. Ocean tides are the most widely experienced result of this, but tidal forces considerably affect also other mechanics of Earth, as well as the Moon and their system. Tides of the Moon. The lunar solid crust experiences tides of around 10 centimeters, 4 in amplitude over 27 days, with 3 components, a fixed one due to Earth, because they are in synchronous rotation, a variable tide due to orbital eccentricity and inclination, and a small varying component from the Sun. 157. The Earth-induced variable component arises from changing distance and libration, a result of the Moon's orbital eccentricity and inclination. If the Moon's orbit were perfectly circular and uninclined, there would only be solar tides. 157. The cumulative effects of stress built up by these tidal forces produces mooncakes. Mooncakes are much less common and weaker than are earthquakes, although mooncakes can last for up to an hour, significantly longer than terrestrial quakes because of scattering of the seismic vibrations in the dry fragmented upper crust. The existence of mooncakes was an unexpected discovery from seismometers placed on the Moon by Apollo astronauts from 1969 through 1972. 158. Ocean tides. The most commonly known effect of tidal forces are elevated sea levels called ocean tides. 159. While the Moon exerts most of the tidal forces, the Sun exerts also tidal forces and therefore contributes to the tides as much as 40% of the Moon's tidal force, producing in interplay the spring and neap tides. 159. The tides are 2 bulges in the Earth's oceans, one on the side facing the Moon and the other on the side opposite. As the Earth rotates on its axis, one of the ocean bulges, high tide, is held in place under the Moon, while another such tide is opposite. As a result, there are 2 high tides, and 2 low tides in about 24 hours. 159. Since the Moon is orbiting the Earth in the same direction of the Earth's rotation, the high tides occur about every 12 hours and 25 minutes. The 25 minutes is due to the Moon's time to orbit the Earth. If the Earth were a water world, one with no continents, it would produce a tide of only 1 meter, and that tide would be very predictable, but the ocean tides are greatly modified by other effects. The frictional coupling of water to Earth's rotation through the ocean floors. The inertia of water's movement. Ocean basins that grow shallower near land. The sloshing of water between different ocean basins. 160. As a result, the timing of the tides at most points on the Earth is a product of observations that are explained, incidentally, by theory. Influence on Earth's magnetic field. According to recent research, scientists suggest that the Moon's influence on the Earth may contribute to maintaining Earth's magnetic field. 161. Influence on orbit and rotation. Delays in the tidal peaks of both ocean and solid body tides cause torque in opposition to the Earth's rotation. This drains angular momentum and rotational kinetic energy from Earth's rotation, slowing the Earth's rotation. 159. 157. That angular momentum, lost from the Earth, is transferred to the Moon in a process known as tidal acceleration, which lifts the Moon into a higher orbit while lowering orbital speed around the Earth. Thus the distance between Earth and Moon is increasing, and the Earth's rotation is slowing in reaction. 157. Measurements from laser reflectors left during the Apollo missions. Lunar ranging experiments have found that the Moon's distance increases by 38 millimeters, 1.5 in, per year, roughly the rate at which human fingernails grow. 162, 163, 164. Atomic clocks show that Earth's day lengthens by about 17 microseconds every year. 165, 166, 167, slowly increasing the rate at which UTC is adjusted by leap seconds. This tidal drag makes the rotation of Earth and the orbital period of the Moon very slowly match. This matching first results in tidally locking the lighter body off orbital system, as already the case with the Moon. Eventually, after 50 billion years, 168, also the Earth would be made to always face the Moon with the same side. This would complete the mutual tidal locking of Earth and the Moon, matching the length of Earth's day to the then also significantly increase the lunar month and the Moon's day, and suspending the Moon over one meridian, comparable to the Pluto-Charon system. However, the Sun will become a red giant engulfing the Earth-Moon system long before the latter occurs. 169, 170, position and appearance. Rotation. Comparison between the Moon on the left, rotating tidally locked, correct, and with the Moon on the right, without rotation, incorrect. The tidally locked synchronous rotation of the Moon as it orbits the Earth results in it always keeping nearly the same face turned towards the planet. The side of the Moon that faces Earth is called the near side, and the opposite the far side. Far side is often inaccurately called the dark side, but it is in fact illuminated as often as the near side, once every 29.5 Earth days. During dark moon to new moon, the near side is dark. 171. The Moon originally rotated at a faster rate, but early in its history its rotation slowed and became tidally locked in disorientation as a result of frictional effects associated with tidal deformations caused by Earth. 172. With time, the energy of rotation of the Moon on its axis was dissipated as heat, until there was no rotation of the Moon relative to Earth. In 2016, planetary scientists using data collected on the 1998-99 NASA Lunar Prospector mission, found two hydrogen-rich areas, most likely former water ice, on opposite sides of the Moon. It is speculated that these patches were the poles of the Moon billions of years ago before it was tidally locked to Earth. 173. Libration. Over one lunar month more than half of the Moon's surface can be seen from Earth's surface. Libration, the slight variation in the Moon's apparent size and viewing angle over a single lunar month as viewed from Earth's north. Despite the Moon's tidal locking, the effect of libration makes about 59% of the Moon's surface visible from Earth. 154. 60. Movement across Earth's skies. The Moon's highest altitude at culmination varies by its lunar phase, or more correctly its orbital position, and time of the year, or more correctly the position of the Earth's axis. The full Moon is highest in the sky during winter and lowest during summer, for each hemisphere respectively, with its altitude changing towards dark moon to the opposite dot at the Earth's North Pole and South Pole. The moon is for 2 weeks every draconic month, 27.2 days, in the sky, in the respective summer as dark moon and new moon. The resulting long moonlight exposure is used by zooplankton in Antarctica during polar night, when the sun is below the horizon for months on end. 174. Apparent orientation. The apparent orientation of the moon depends on its position in the sky and the hemisphere of the Earth from which it is being viewed. In the northern hemisphere it is seen upside down compared to the view in the southern hemisphere. 175. Therefore the moon's crescent can be seen in the tropics as a smile-shaped crescent moon. 176. Albedo and color. The moon has an exceptionally low albedo, giving it a reflectance that is slightly brighter than that of worn asphalt. Despite this, it is the brightest object in the sky after the Sunday, 60 K. This is due partly to the brightness enhancement of the opposition surge. The moon at quarter phase is only 1/10 as bright, rather than half as bright, as at full moon. 177. Additionally, color constancy in the visual system recalibrates the relations between the colors of an object and its surroundings, and because the surrounding sky is comparatively dark, the sunlit moon is perceived as a bright object. The edges of the full moon seem as bright as the center, without limb darkening, because of the reflective properties of lunar soil, which retroreflects light more towards the sun than in other directions. The moon's color depends on the light the moon reflects, which in turn depends on the moon's surface and its features, having for example large darker regions. In general the lunar surface reflects a brown-tinged gray light. 178. Apparent color. The changing apparent color of the moon filtered by Earth's atmosphere. Viewed from Earth, the air filters the reflected light, at times giving it a red color depending on the angle of the moon in the sky and thickness of the atmosphere, or a blue tinge depending on the particles in the air. 178, as in case of volcanic particles. 179. Cultural references. The terms blood moon and blue moon do not necessarily refer to circumstances of red or blue moonlight, but are either particular cultural references such as particular full moons of a year. Phases. The moon is always illuminated the same amount by the sun, but the illuminated area of the visible sphere, degree of illumination, is given by where is the elongation, i.e., the angle between moon, the observer on Earth, and the sun. The monthly changes in the angle between the direction of sunlight and view from Earth, and phases of the moon that result, as viewed from the northern hemisphere. The Earth-Moon distance is not to scale. Apparent size. Comparison of angular diameter of Moon compared to other celestial objects. To get a true representation of this image, view it at a size of 5 cm wide on your monitor and at 5.15 m distance. The moon's angular diameter is about 0.52 degrees, on average, in the sky, roughly the same apparent size as the sun. See eclipses. The distance between the moon and Earth varies from around 356,400 kilometers, 221,500 mi, to 406,700 kilometers, 252,700 mi, aperigee, closest, and apogee, farthest, respectively, making the moon's apparent size fluctuate. Moon illusion. The moon does appear larger when close to the horizon, but this is a purely psychological effect, known as the moon illusion, first described in the 7th century BC. 180. Illumination and brightness. Half of the moon's surface is always illuminated by the sun, except during a lunar eclipse. But also Earth does reflect light onto the moon, observable at times as Earthlight when again reflected to Earth from the near side of the Moon where it is not illuminated by the sun. Day reported as a supermoon. On the 14th of November, 2016, the Moon was at full phase closer to Earth than it has been since 1948, 14% closer and larger than its farthest position in apogee. 181. This closest point coincided within an hour of a full moon, and it was 30% more luminous than when at its greatest distance because its increased apparent diameter. 182, 183, 184, at lower levels. The human perception of reduced brightness as a percentage is provided by the following formula: SAD Smiley 185, 186. When the actual reduction is 1.00/1.30, or about 0.770, the perceived reduction is about 0.877, or 1.00/1.14. This gives a maximum perceived increase of 14% between apogee and perigee moons of the same phase. 187. Eclipses. The Moon, tinted reddish. During a lunar eclipse, the fiercely bright disk of the Sun is completely obscured by the exact fit of the disk of the dark, non-illuminated Moon, leaving only the radial, fuzzy, glowing coronal filaments of the Sun around the edge. The bright disk of the Sun, showing many coronal filaments, flares and grainy patches in the wavelength of this image, is partly obscured by a small dark disk. Here, the Moon covers less than a 15th of the Sun. From Earth, the Moon and the Sun appear the same size, as seen in the 1999 solar eclipse, left, whereas from the Stereo B spacecraft in an Earth-trailing orbit, the Moon appears much smaller than the Sun, right. 188. Eclipses only occur when the Sun, Earth, and Moon are all in a straight line, termed SYZYGY. Solar eclipses occur at new moon, when the Moon is between the Sun and Earth. In contrast, lunar eclipses occur at full moon, when Earth is between the Sun and Moon. The apparent size of the Moon is roughly the same as that of the Sun, with both being viewed at closer to 1/2 degree wide. The Sun is much larger than the Moon, but it is the vastly greater distance that gives it the same apparent size as the much closer and much smaller Moon from the perspective of Earth. The variations in apparent size due to the non-circular orbits are nearly the same as well, though occurring in different cycles. This makes possible both total, with the Moon appearing larger than the Sun, and annular, with the Moon appearing smaller than the Sun. Solar eclipses. 189. In a total eclipse, the Moon completely covers the disk of the Sun and the solar corona becomes visible to the naked eye. Because the distance between the Moon and Earth is very slowly increasing over time, 159, the angular diameter of the Moon is decreasing. As it evolves toward becoming a red giant, the size of the Sun, and its apparent diameter in the sky, are slowly increasing. L. The combination of these two changes means that hundreds of millions of years ago, the Moon would always completely cover the Sun on solar eclipses, and no annular eclipses were possible. Likewise, hundreds of millions of years in the future, the Moon will no longer cover the Sun completely, and total solar eclipses will not occur. 190. Because the Moon's orbit around Earth is inclined by about 5.145 degrees, 5 degrees 9, to the orbit of Earth around the Sun, eclipses do not occur at every full and new moon. For an eclipse to occur, the Moon must be near the intersection of the two orbital planes. 191. The periodicity and recurrence of eclipses of the Sun by the Moon and of the Moon by Earth is described by the Saros, which has a period of approximately 18 years. 192. Because the Moon continuously blocks the view of a half-degree wide circular area of the sky. M. 193. The related phenomenon of occultation occurs when a bright star or planet passes behind the moon and is occulted, hidden from view. In this way, a solar eclipse is an occultation of the sun. Because the moon is comparatively close to Earth, occultations of individual stars are not visible everywhere on the planet, nor at the same time. Because of the precession of the lunar orbit, each year different stars are occulted.